Which of the following forces cannot do any work on a moving particle? That would be the magnetic force. But let's look at all these situations. Let's say we just had a proton and it was moving, and here's Earth, and gravitational effects were significant. Then the force on this particle towards the center of Earth would be constant, which causes an acceleration towards Earth. And it would be speeding up. Well, the force wouldn't be increasing, but the speed would be increasing as it fell. Projectile motion, right? So since the particle would be speeding up in the vertical direction as it fell, it would be changing energy, which means the gravitational force is doing work. An electric force, well, this is how we can accelerate a particle. Let's say we have a capacitor here, and we put a proton there. What's going to happen? Well, it's going to feel an electric force to the right due to these positive charges. It is repelled by them, and it will speed up. It will accelerate towards the negative plate. So since it's speeding up, its energy is changing due to work. So electric force can do work. Frictional force, yeah. So let's say it was a particle is going through a material. There can be a drag force on it due to that material. It can slow it down. So it can do negative work. Magnetic force, however, so if we have a field here and we have a particle, it's just going to start traveling in a circle. How are these situations different? Well, as you can tell, that even as this particle is speeding up in the downward direction, it's a constant force in the same direction. So here, that's not true, because here the force is going to be this way, but once the particle's over here, now the force has changed direction so that the displacement and the force are always perpendicular to each other, which is not the case up here. So that is why the answer is D.